So today's extending option is figuring out how the least squares regression line actually works. So it's cool. You type into Desmos y1 tilde m x1 plus b, and then boom, it just makes you a line of best fit that's way more awesome than the one that you came up with in your own brain. I have actually myself been wondering how this works for a while. So I have this cool tool that helps you explore it a little bit more and hopefully helps you come up with a reason why it might be called the least squares regression line. Okay, so remember when we just did residuals from yesterday or maybe the day before? Remember that a residual is a measure of how far a prediction is from what's actually observed. So the residual is the actual minus predicted. So when we look here, these red lines are going to represent the residuals because they're the distance of the point, like the vertical distance, from the line of best fit. Okay, so when Desmos or a graphing calculator is finding the line of best fit, it's trying to minimize the absolute value of these residuals. Or it's trying to imagine that they're all positive so that it can compare them and then make their distance from the line of best fit the least. So sometimes there are several different lines of best fit that can be drawn with the same sum of absolute values of residuals. To create a single unique line of best fit, statisticians use the sum of the squares of the residuals instead of the absolute value to make all the residuals positive. Now, you might be like, what the what right now? So let's kind of look at this investigation a little bit that you're going to do. So if we click on this link here, it gives us what looks like a thing we've been doing a lot. You'll notice there's some points and there is a line that you can move and adjust with a graph. So notice that you can totally move the points around. You can also move this line to kind of look like its line of best fit as best as you can. So it first tells us, using the settings on the E tool, show the line of best fit in the residuals. Hide the squares in the least squares regression line. Okay, so the line of best fit is, I think, the red line. And then it also said what show the residuals. Okay, so I'm going to click, if I click this button here, it'll show me the residuals, which is cool as I move my line of best fit around because check it out, it like adjusts the residuals some. Nice. Okay, now you're going to look down and you're going to find the lowest sum of the residuals that you can find. So if we go down to the bottom of this, it says sum of the residuals, and you want to make that number smaller. So far it seems to be, I don't know if I can get lower than 23. But yeah, so you're going to go for the lowest number that you possibly can there. And you'll type in some answers because there's questions about this back on the ClassKick or back on the Google thing. Okay, then B. Since there's sometimes more than one line that has the least sum of residuals, mathematicians minimize the sum of squares instead. Using the setting on the E tool, show the line of best fit in the squares. All right, get ready for this. This is where it gets cool. So if I click here, I suddenly have squares. And so now when I move this tool around, the squares get bigger and smaller. And the squares are cool because when you look at squares, it doesn't really matter if you're looking at something that's above the line or below the line because it's just squares. It's the distance from the line squared. Okay, so now we're going to find the lowest sum of squares that we can. So again, this tool right here has stuff. Right now I'm at 79. Looks like I can go down to 78, 77, 76, 75, 74. Ooh, I'm getting pretty small. Oh, but then I start going up again. So maybe my line of best fit looks something like that. And now, let's see. C, use the E tool to show the least squares regression line. There's only one least squares regression line that minimizes the sum of the squares. All the other lines have larger sum of squares. So if you click this thing, then it shows you that's like the real one. And check it out, we were actually really close. And by we, I mean me, because you're not really here. So good job, Miss Leckness. Yeah, so you can do that. And what's nice is that now I can like mess it up and I can adjust things and I can change the points all over the place. And I can hide this least squares regression line again and then mess it up some more because I already know the answer. And then I can practice like making a smaller sum of squares and knowing that that's actually what the computer, what Desmos is really doing. So I want you to go back, like play around with this sum, figure it out, and then go back and answer some of these questions either in the class kick or in the Google document. And like what I really want you to know by the end is like what was happening with the squares. And in conclusion, why do you think that the line of best fit is also called the least squares regression line? Notice it's in caps for a reason. Why does that name make sense? And if you have questions or you want to explore this with me some more, come talk to me. Go Burke.